Oh yeah, that's the mixture you want. Okay, oxygen on a diode laser. Will it allow us to cut through thicker metals, or will it end up being the death of me? Either way, let's do it for science. I want to say that Xtool, nor any of the brands that I show here in my videos, are affiliated with the dangerous and/or unpractical uses I demonstrate. Everyone using any machinery should always look to a credible source for safety of your equipment, yourself, and those around you. With that said, remember your eye protection, fume extraction, get a laser enclosure, don't take off the laser shield, and never leave your machines unattended for any period of time, ever.
The views and opinions expressed in these videos are those of the individuals and do not necessarily reflect the views and opinions of Xtool or any other brands that I may show off here.
I do appreciate everyone's concerns for me, and one of the comments recommended that I get a arrestor, a flashback arrestor. That's this little thing right here. And then some other comments said that an oxygen line does not need a flashback arrestor. I will be honest with everyone, I really didn't know much about oxygen before reading through all the comments and doing a little bit of research myself. Just please, don't do as I do. Okay, with all that out of the way, let's plug in this oxygen and see what it does. This is a very old propane and oxygen torch. Using a torch like this, you turn on the propane first and you light the propane. With the propane, it's a yellow flame. It's not very hot. You can add the oxygen, get more of a blue flame. Oh yeah, that's the mixture you want. Oxygen by itself is not flammable. That is something I didn't know. Not until reading your comments and doing my own research. I always thought oxygen was extremely dangerous by itself. But the truth of the matter is this is an oxidizer. It must have a fuel to be dangerous. The first thing we need to do is get the tubing onto this connection point here. It's going to be a little tight, but if I twist it on, it's going to be just fine. Okay, and we have the valve on top of the laser in the closed position. I'm going to go ahead and open up the oxygen all the way, turning it to the left. I also have a fire extinguisher ready to go, just in case. Let's go get some metal and see what we can do with it. Okay, from before the 40 watt, we were able to cut through the 0.305 millimeters. It took 3.25, 3¼ passes to cut through. And we ran that at 3 millimeters a second. We're just gonna run the same thing. And this was with 40 PSI, just compressed air. I don't believe we can reach that with the valve that I have. The pressure seems pretty low. I'll let you listen to it right here. But this will be our first test and let's just see what it does. All right, oxygen on. Wow. Do you see what just happened? Oh my word. So that was much hotter than before. As you can see, it's just tearing through the metal, melting right through it. This is the back side. Ooh, there's a lot of heat there. Let's just try it, but we'll go much quicker. I really can't tell what's going on. I'm gonna take the shield off again. This is just for demonstration purposes, so that we can actually see what's going on here. Okay. Wow. We've got to figure out how to dial in these settings. because that is just demolishing the metal. Look how hot that is. I don't know what we need to do a better cut. Really, I'm curious just to put in some really thick metal now. I have some 22 gauge. It's substantial. 4 millimeters a second. Oxygen on. Okay, I do not believe we cut through. I'm curious to see the back side. There's like a protrusion, but no cut. Nice thing about this metal is it's not warping from the heat that I can tell. Okay, let's slow it down. Let's try 2 millimeters a second. Okay, I'm gonna stop it there. That's what's going on here. Oh, do you hear that? No, you don't, because that means we're out of oxygen. No. Looks like I need to go get some more of these. Got another tank. Surprisingly, they have these at Ace Hardware as well as Tractor Supply. They are $16 a piece, and I did check some reviews, and people are saying that they only run for about 10 minutes. Now, this is the valve that I'm using, and it's got a very small channel there on the bottom, and I think that's kind of why we're getting the low PSI when we're running these tests. I probably need to look into getting some different valves, but I do just want to show you, these aren't low pressure. Don't do this at home, please. I'm going to push on the pin here, and we should be able to hear the pressure. Yeah, a lot of pressure. I think I read online that it might be 400 PSI. Keep in mind, the low PSI that we are getting today is most likely because of the valve that I'm using. I have not really looked into modifying this or purchasing different types of valves. Okay, this test is going to be just a tiny circle with 1,000 passes to see if we can just pierce through this sheet of metal. Start the test with no oxygen, and then I will introduce it in a few seconds. Does not seem to be working. I was viewing it from the underside, and nothing was penetrating through. Just won't penetrate. So on this metal, it seems like the oxygen really isn't even making a difference, and I think that has to do with the fact that we're not really penetrating through the metal and giving it a place to go through the cut like it was on the thinner stuff, where we saw clearly it was like melting the metal like it wasn't even there. I don't know what we need to kind of take it to the next step. I'm wondering if I should try to alter the valve on that tank to see if I can get more PSI out of it, or if I just need to stick with thinner metals at this point with this amount of power. This is a 40-watt diode laser. It's the strongest diode at this point. It's not a wavelength that's made for metal. It's not like a fiber laser would be. So we are kind of pushing the boundaries on things that aren't even really tried yet. Okay, so I've been playing around with the laser, cutting metal with the camera off, just so I can move a little quicker, get my stats figured out. Finally figured out how to do the pierce on light burn. Click your cut line, and if you go to advanced, you got this thing called cut through, and you can turn that on, and you can set however much time and power you want it to sit at the beginning or the end of a cut. But for some reason, it's not working here with the Xtool. I have seen someone in the comments that say it is working with their G-code machine, but for some reason the Xtool is just not recognizing the cut through. Now my workaround is this. You zoom way into the corner here. I have drawn a tiny little circle. Now you can't get too small, otherwise it won't recognize it. I was able to get this sized down to 0.0005 inches. I set it to do 100 passes, 0.05 speed, and that makes it pause there for a few seconds. If I want to increase that, I can just add more passes. I make sure that that blue color is on top so that it is the first process to run. And that's allowing me to create a pierce on the metal before speeding up to the quicker speed. I'm doing some comparisons between normal compressed air versus oxygen versus low pressure versus high pressure. All right, I want to show you what I have just learned recently. We're going to do one with no air, and this is at 5 millimeters a second. Now with that, you can see it did not cut through. No cut. I'm going to move it a little bit over to the right. Now I'm going to do a low pressure, low PSI compressed air. Okay. Still no cut through. I'm going to move it over to the right. And now I'm going to do high pressure. Okay. Earlier that was popping through. Maybe I'm going too fast now. That takes away the legitimacy of my test. That was supposed to fall through. Did earlier, I promise. I was getting the same results up here. Okay, so here, this is no air assist. There's the pierce through. You can see that worked. Here is the low pressure. Still got our pierce through. And here was the high pressure. You can see we were actually getting a cut. For some reason, it did stop cutting right in there. We may have come out of focus from warping. We got to test oxygen. I don't believe it cut through either. Sad. I don't feel like we're getting enough oxygen. Compressed air again. 3 millimeters a second. Finally, that's a result I like to see. Okay, so that's going to be our control. Now we will take it and switch over to oxygen and see if there's any difference. To me, it looks like it did not cut through. Could we be too far away? This will cause the laser to be more out of focus, but maybe it will help it. Oh yeah, it's doing something. Okay, that's an interesting result. You can see it completely melted through the metal that time. So that's what we're wanting with the oxygen. I think the problem is the nozzle that we have on here is too far away, the amount of PSI that we're getting out of this oxygen. Switch to compressed air. Yes, we can still cut. I'm curious. Can we cut better? Let's go back at the 6 millimeters a second. This is twice the speed. Sure looks like it. With the metal, the focal point doesn't really matter. It looks like getting the laser beam or the nozzle closer to the cut is better. Same thing with the 2x4. When I cut through that, it was all about making sure the nozzle was nice and close. What does it do with oxygen? Can we get faster with the oxygen? We can melt everything with the oxygen. Look at that hole. Holy moly. Like, let's go twice as quick. 12 with oxygen. Oh, Lord. Just demolishing it. And that is so bright. Sad. We just ran out of oxygen. I'm really not sure what to think or where to go at this point. I've used $30 worth of oxygen on these tests here. So I think I'm gonna right now go and buy an oxygen generator, produce my own oxygen, and figure out how to get it compressed up to the 40 PSI that I want. So for now, we're gonna put oxygen on hold, and then we will revisit this whole setup and see whether oxygen on a diode laser is a viable thing or not. And I'm really curious to hear what all of your thoughts are, because I really am just a guy in a garage with some tools and it's dangerous. Don't do it at home. But I want to hear your thoughts. There are a lot of brilliant minds out there watching these videos, and I really appreciate all your constructive criticism. I feel like we are learning together in this journey, and I'm happy to be the one who does the test for everyone so we can see what we can do. Until next time.